So as I said, we'll have inshallah three workshops. This is the first one. So this is more of an introductory one. But the goal is really to understand the foundations of LLMs and everything that entails them, plus how do we build applications around them. I'll give you enough examples, inshallah, about them. You guys are familiar with Medina Labs. I don't have to go over this, but basically, this is one of the things that we do, which is going to be the workshop, and ideally, this is the vision is to empower the community really to build stuff, to own stuff, right? Not to just become employers for others, and to empower the ummah, inshallah. I did have who attended my last workshop was in July. Okay, we have two. Okay, great, just to know. So we do have workshops, a lot of workshops. So these are part of it. But let me talk a little bit about myself. For those who don't know me, I just put everything I can put here. So I work for a company called Incorta. Incorta is in Foster City, California. I just came actually last night. It's an end-to-end data management and analytics platform. We serve companies like Broadcom, Apple, Comcast, and so many other companies. We've raised about $250 million. So inshallah, we will get a good exit, so we're about 2 billion valuation, alhamdulillah. Founders are Muslims, Sam Al-Qadi and Hisham Salami, an Egyptian and Tunisian, mashallah. Prior to that, I worked for Volvo Cars. I worked in the autonomous drive function, and later I built their data science platform. I graduated from Jackson State University. I have a PhD in computer science, specifically machine learning. And I got recently my MBA from University of Illinois, Urbana-Champaign. I did work for several companies, C-Spire in the South when I was there. It's a telecom company. I worked on the algorithm that detected anomaly detection. Basically, I was practicing my PhD as an intern with them. I graduated from, I went to University of Malaysia. So if you're from Malaysia or around Malaysia, it's called UUM. I also studied at Al-Azhar University. Alhamdulillah, Allah subhanahu wa ta'ala has blessed me. Graduated with a bachelor's degree as well. I led several, and again, I'm just giving you an example of how we should not just focus on work. You could do both. And yes, it's hard, but it's manageable, inshallah. I was the head of da'wah at MCA in the Bay Area before I moved here. I moved last year, actually, in October, subhanAllah, to this community, and alhamdulillah, I'm blessed. I was the Amir of Yasin Foundation for several years, and I also led their Taraweeh for about 10 years, alhamdulillah. I was part of WVMA as well, and some other stuff. You probably saw the black hole, the image. Remember the big stunt that, okay, so I was part of the team that worked on the infrastructure. It used to be called Exceed, and alhamdulillah, they also wrote an article about that. I worked for a bunch of startups, Extrava, others. I was part of the SINET. That's exactly what powered, the black hole. SINET is the fastest networking, infrastructure. It happens every year. It takes about a year to plan, a month to build. A year to plan, a month to build, a few days to operate, a week to operate, and a day to tear down. So it's more of an experimental one. It happens at the supercomputing conference, which I was part of organizing. Yeah, I like hiking, biking. I recently lost my ACL, alhamdulillah, reconstructed, so I'm back, inshallah. So if you're into biking, hiking, I don't know, I need to learn more about Michigan, but I know it's going to be winter. But alhamdulillah, and I have 4 kids, alhamdulillah, Fatima, Harith, and Jenna. Any questions? Okay, barakallah fikum. Okay, so as I mentioned in the beginning, so many things are happening every week. There's an LLM that comes out. There's a model that comes out. So we just want to navigate so that we separate the hype from the reality. And some of these models are open source. Some of them are closed source. APIs, framework. I work with executives all the time. We're fighting, last Friday. So should we just go with, Claude? Should we build our own? Should we do this? Of course, we do have a little bit of everything, but how, from a strategy perspective, where do we go from there? And then how do you frame the business, the business question? What problem are you trying to solve? and how LLM will be helpful there. And of course, the most important thing is, yes, you can prototype, and it's beautiful, it's amazing. But then once you put it in production, it becomes a problem. Cost becomes a problem, scalability becomes a problem, safety. So how do you learn about the underlying infrastructure so that when you design them, you have these things into the considerations, inshallah. Now it's three workshops. Of course, you're not going to be an expert, but at least you will have a clear idea how to build LLMs in your software. Anybody here works with LLMs? Raise your hand. Okay. By working with LLMs, I mean like you embed them in your software. Yeah. Okay. All right. Anybody has used ChatGPT? Okay, then you worked with LLM, right? But of course, we'll go a little bit beyond that, inshallah.
Define work.
Huh? Yes. But work means you have interacted with them at least.
Well, you mean like you embed, yeah.
Yeah. Okay. So what's the prerequisites for me to understand and to go over all the workshops? You have a charged laptop. Who doesn't have a laptop? It's fine. You're going to learn a lot today, inshallah. But it would have been better if you had a laptop. If you don't have a laptop, find somebody next to you who has a laptop so we can practice. Because believe me, concepts are amazing. You will learn a lot from concepts. But by the time you leave, a week later, you'll only retain probably 10% or probably less. If you just put your hands on some of these concepts, you will learn a lot. We have the lab notes. Please go to bit.ly/Medina-labs. Everybody, right now, and tell me if you can see the.
You need access.
The PDF file. Did you go to? I think I give everybody an access.
But what can I access? Viewer or editor?
No, I just said. Okay. Let me see. Allahu Akbar. Yeah. Okay, then I have 2 copies of the same file. Okay, so everybody should be. Yes, and from now on, inshallah, this is going to be the link, at least for my workshops. So you're able to, like, anything new, anything we talked about, and I tell you, okay, I'll put it later in the document. So this is like your entry point to the entire materials, including the slides. The slides might not be accessible now, but I'll make them accessible after the class. You need a programming language, preferably Python, and you should be okay with it, like good with it. If you want to refresh and you think you're rusty a little bit, Python from Google, and you'll have the slides afterwards, so you'll be able to click on this. And also, there's a very nice course that I gave some of the mentees that I have, and mashallah, they started building agents and amazing stuff after, of course, with weeks and weeks of hard working, but all of them unanimously told me this was an incredible course because it doesn't just deal with Python for everything, it deals with Python for AI. So you will understand the libraries, you know how to interact with these LLMs, and and so on.
First condition here.
Yes.
What if it's not fully charged? What do you do?
That's why I said charged.
I'm sorry, it's a Windows, so.
I know. Inshallah, if you can go to the end. Yes. Yes, I'll get you the slides, inshallah, afterward. All right. Any other questions so far? I hope everybody got the notes. No, you should be able to access them. If you say Medina/labs. Who was able to access?
We need to request
slides, yes. Slides, I'll give it to you after the class. I might add something, I might remove something. Yes. All right. So, why are we here? Why LLMs? Why companies are rushing, and it's crazy. So, McKinsey have a report, and I put the link here. They're saying that could add $1 trillion to the economy, and you probably saw recently Oracle invested in OpenAI invested in NVIDIA, everybody is investing 100 million. OpenAI, for example, now, does anybody know the valuation? So last July, valuation in OpenAI was what, 80 billion? Who knows the valuation today? From July, my last lecture to today, it's $500 billion. Yeah. That's the valuation of. So it's gonna be, it's gonna take over, all the big ones. And it's OpenAI, right? So they said, you know what? It's OpenAI. We have this lawsuit. We should be open. We started as a non-profit organization, but we are for profit. Microsoft enabled us. So what do? They took 100 billion, just on the side, and they gave it to the what? To the non-profit section of it. Just 100 billion. Just to tell you, it's going to be literally trillions of dollars. Whether it's with LLMs or not, I'm talking about generative AI. So how do you generate content? How do you generate the next token? It doesn't matter. Whether it's LLMs or others, we know for a fact now we have applications for it. Okay, and by 2026, which is a few months, right? More than 80% of enterprises will have used GenAI application or API in any shape or form, whereas end of 2023, there are only 5% of companies. So if you're looking for a job, some generative AI has to be there, whether it's content. Because right now, for example, I was talking to our the head of marketing. Her name is Nuha Rizq. She came from Facebook. She was the CMO at Facebook, Chief Marketing Officer at Facebook AI, and now she's at Incorta. She was hiring someone, and I was talking to them. And when I was looking for hiring them, just marketing, right? I was looking for their GenAI ability. Have you used, tools like Jasper AI or, Google View 3 or how do you have you interact with these tools at least if you're not building them? May Habib, she has a company called Ryder. She's a good friend of mine. She said just talk to a Fortune 10 company, and they're spending about $3 million a month per API calls, right, to LLMs without not even a use case. Just to tell you how obsessed companies are with that, because everybody wants that gold rush. They're just afraid to miss out, right? Okay, so what is generative AI? Where is it? We hear AI, Gen AI, deep learning, machine learning. What does that mean? Artificial intelligence is the big picture. It's like when these tools and machines are thinking and behaving just like a human, 100%. That's why we call it artificial, right? Machine can do that exactly the same. And then we started, we're talking about from an algorithm, right? Right now we're talking from an algorithm perspective. Machine learning came in, right? It's been there since probably the 50s, right? Some forms of machine learning. As we progress, as we went from the 50s until today, machines are becoming more powerful. Data is becoming more powerful. And now these fields are becoming more and more mature. The big moment for deep learning was machine learning was actually around 2008 and 2012. That's when people really start to use big systems and big data enabled also that. Deep learning, the big moment was in AlexNet, an algorithm that came out where they were able to feed an algorithm pictures, and the algorithm was great in classifying these pictures, cat, dogs, right? And that was in 2012, around 2012. And then things kept progressing until 2017. A paper came out, and that's why we are here today, called the Transformer paper. And I'll show you, we'll talk a little bit about it. And they came up with this algorithm, which is an amazing algorithm called the Transformer. But nobody knew much about it until end of 2021, when it was really put into application. So the learning lesson is technology might come out, but then finding an application for it takes time. From 2017 to 2021, until we saw something working. So they've been working on it. I worked on earlier GPTs, GPT-1, GPT-2, when it came out, GPT-3, until everybody knew about it in around 2020, end of 2022, when it was called 3.5, right? GPT 3.5. That's when people start feeling that they're interacting with something intelligent. So bottom line is, whatever you learn today will be applicable probably, we'll find big applications for it probably in the future. I will teach you some of these current applications, especially for companies in the enterprise, but we'll talk more about it as we go. Now, you probably heard of big data, data science, data analytics. They intersect. So a data scientist would use machine learning algorithms, would use deep learning algorithms, would use generative AI to actually work with data. Data analysts, they're not, but now, as I have seen, they're getting closer and closer. So if you're in the data analytics space, you need to get into generative AI. Any questions so far? Yes?
I teach algebra and statistics, and
MashaAllah.
Statistics used to be a chapter in algebra, but now it gets its own.
Mm-hmm.
And if you're in California, they rewrote like the whole data science track.
Yes.
They wrote the calculus track. How can I apply this for my students? The Venn diagram.
So I'll give you another Venn diagram after the class. I'll put it inshallah in the slide. But data science is literally three Venn diagrams. The first one is what you mentioned, linear algebra and statistics. The second one is the domain where the data is coming from, let's say cybersecurity, or and the third one is the ability to construct the research for deep learning. So definitely not just algebra, but linear algebra, that's a specific one, and of course statistics. These are very important skills for a data scientist.
I'm hearing sample, I'm hearing vector.
Yes. Yeah, that's a good way of abstracting it. Okay. Yes.
What happened towards the end of 2022? The transformer models was relatively older than this. Wasn't it like the fact that like the early pioneers of OpenAI, they figured out what's keeping them from this advancement is the large data volume.
Yes, scalability.
Wasn't that like really the breakthrough?
Yes, but they had early sparks of intelligence prior to that as well.
But
they, of course, they figured out it's two things.
Yeah.
The more data you throw to it, the more compute you throw into it, the more intelligence, right?
Yeah.
Let's say that's the lazy way of doing things, meaning we don't have time, we're not going to figure out, what algorithms we need to come up with. Let's just throw, because the transformer was scalable enough to apply to different domains.
And that's what OpenAI figured out
yes,
earlier.
yes, yes.
Yeah.
Even though now, if you remember when DeepSeek came out, they scared every investor, and NVIDIA's stock went down because they kind of like touch on the common perception that, just throw more compute, throw more, more compute into it, and you're gonna, of course, the more compute, the better. But then it scared the investors, like, maybe there's something, different than just the compute. But as of now, it's compute and data. Okay, any questions so far? So Andrej, I don't know if you guys know Andrej, is well known, is he coined the word vibe coding, he coined the word software 2.0. But software 1.1 was, you write a program, you have the logic, you write the logic for it in a program, right? And then you find a compiler, interpreter, and now you have a machine, a code that you deploy, and that's the software that you have. And that's how it's been until machine learning came in, and deep learning, and matured enough, especially with deep learning, because with machine learning, we used to engineer these features. Like, if you have a table, the dependent, independent variable, we used to over-engineer. It takes like months and months to just find the right, parameters to get the right output. But then deep learning came in, and then all of this, like, just throw the data to the algorithm, and the algorithm will figure it out. And again, I'm oversimplifying. There's so much into it. I'm just giving you the big picture, and next week's, inshallah, we'll deep dive more. So what happened is we get the code, and the code is we don't code the logic. We code how to deal with data, like how to get the data, how to find patterns. Now, with certain deep learning architectures, and I'll show you, and the transformer is just one architecture. And then the programmer code, all of them with an optimizer and the compiler, you get a machine code and a statistically based machine learning model. Meaning, the algorithm will figure out a pattern within the data, and this becomes my program. As the data changes, my program changes. This was revolutionary, because now I don't have to statically write my code. So my code is changing as the data is coming. But then with software 3.0, which is we're discussing today, it's even crazier, because now these agents, in natural language, they made the barrier for the entry way less. In natural language, you're able to say exactly what you want. Of course, there's so much complexity. Like when you architect a system, it's way more complex. And you will see today when you build your first RAG, inshallah. Yes? Say yes. Okay. You will see that it takes a lot of code, and that code is not for the logic, like how do I retrieve the data? No, that code is how do I connect things together, and then how to instruct this agent to do things for me. So once that agent is built, That's it. That becomes my flexible program. And then, of course, you get the machine program and the statistical program. Highly recommend you watch the video. It's about an hour. It's literally going to change the way you look at software, especially if you want to do software. Any questions so far? No? Okay. So you hear agentic AI, right? How did we go from GenAI to agentic AI? So you have an LLM, and I'll explain exactly what an LLM is. Think about it as a file that has all the knowledge of the world. You query it, you get an answer back. That's a very easy way to abstract it. Came in 2023, early 2023, late 2022. Everybody jumped. We query it, amazing. You start asking questions, it gives you an answer, beautiful. Until now, it's cool, everybody's happy. But then, when we took it to real applications, I want to put it in my company, I want to do something with it, it hit a limitation, right? In 2024, Trump took the office, 2025. You ask it, it tells you the president was what? Joe Biden. Why? Because the cutoff time, right? So we need to augment, right? That's RAG, retrieval-augmented generation. You retrieve the right data, you augment it with the knowledge that already stored in the LLM, and now you generate the answer based on that. So these two together, now we started to see, intelligent systems. Wow, it's not just stupid. It does not just act out of its understanding, right? And of course, there's so many ways to change the behavior. There's fine-tuning, and we'll talk about each one of them. But I'm just telling you how we went from here to here, right? And then we're like, okay, I retrieve the right data. I give it to the LLM. Now it starts reasoning about it. It gives me something. And then the reasoning models came out, and I'll explain what that means. And then we started giving it tool. Give it an API. You give it an API. You say, hey, these are a bunch of, let's say, two APIs. One does search, goes to the internet, does search, comes back. And what's, say, for example, a calculator. And now, all of a sudden, the LLM knows how to use these tools, the API, and the RAG, retrieve the right data, and it gives us what? Very good answers. This was not enough. Because as the tool expanded, as the RAG became more complex, agentic RAG, you have multiple architectures. Anthropic came up with a new protocol. They're like, let's govern this. Let's make this a system. So they created something called MCP. Does anybody know what MCP stands for? Model Context Protocol. Because what am I doing here? I'm giving the model what? The context, right? Maybe the context it has, like the knowledge it has is not enough. I'm giving it good context, right? So when you write a prompt, you're giving it a context. When you retrieve the data with your prompt, that's a context. So we needed a protocol that gives the LLM that context. And you probably heard the function calling. So it calls. So this becomes the context that you pass to the LLM to make decisions. And this was the birth of agent. Now, but one agent is not enough. Again, it's gonna go and it's gonna get crazier. One agent is not enough. I need what? More agents. And I need more agents so that I have a whole system. So Google came up with something called what? ATA. ATA is a protocol, agent-to-agent protocol, meaning I don't care. Maybe he will build an agent, you will build an agent. I don't care about what LLM you're using, Anthropic, OpenAI, whatever. You could use a bunch of tools, but I need some sort of an interface where an agent will come with a card and say, hey, my name is Lilala, this is what I can do. It's like a JSON card that tells me exactly what you can do. And we make that introduction and we start using each other's services. So that's the protocol that we use right now. This was built by Google, and Incorta was one of the companies that contributed to this. So about 50 companies that contribute to this. I was leading that team as well. Any questions so far? Yes?
You started in 2023.
Yeah, 2020, end of 2022, 2023. Yeah, that's, of course, LLMs have been there. BERT, if you heard of BERT before, Google has like multiple ones. They've been there, but this is like when people started to make use of them. Yes?
My question is for the absent students that miss a day or a week of class. How much time is between these steps? From the first step to the A to A?
Which class you mean?
My students. They can be absent. We have an absence policy. We're struggling with chronic absenteeism.
Okay.
So how much time is between your 5 different things?
This is more of a conceptual way of putting at it. I'm just saying, like, how do we went from GenAI, generative, because people say GenAI, and now everybody is saying agentic AI. Why do we say agentic AI? We're still using the generative models, but now it's becoming more sophisticated, meaning there's protocols involved, there are tools involved, and that's how things are pieced together. Yes?
How do the RAG and the tools talk to each other and respond to each other? Is it
Right now, just to simplify it, MCP. MCP is the USP that connects all of these together so that the LLM can actually think and reason about these tools and the RAG. Yes?
BERT is an LLM or is it just the encoder?
It's encoder, decoder.
So what's LLM then? I thought that was LLM comes later.
Yeah. So let's say it's an early form of an LLM, right?
Precursor.
Yes. Okay, so a large language model, when we say LLM or large language model, it's a large general purpose language model that can be pre-trained and then fine-tuned for specific purposes. And I'll explain each one of these in my description. Again, why do we learn the basics? Because I just don't want you to use these LLM blindly. Because if you use them blindly and you don't know the purpose, you will misuse them and you're not going to find them useful. So GPT is, G stands for generative. P is pre-trained, meaning I have a lot of data. I trained it using an algorithm, and now I have a binary file that's sitting somewhere that I'm querying, right? T is transformer, which is the algorithm that was used to generate this. There's also vision models, meaning data that was trained on videos and pictures. And there's also something called multimodal, and that's pretty much the default now. So GPT-5, Gemini 2.5, all of these are, meaning like when they trained it, they didn't just put text. They put text, they put videos, they put audios, and we'll talk about the encoding. Yes?
I'm sorry, what was the P again?
Pre-trained.
Pre-trained.
Meaning like all the knowledge, remember I said all the knowledge is in a file, and that's what we're going to talk about. Okay.
Question.
Yes?
Until what version of the GPT was it just text-based?
I would say until 3, 4, it became more multimodal. Yes. Afan, did you raise your hand? Yes, sure. We'll share the slides, inshallah. Okay, so what can they do? Of course, you guys experienced it, right? From a user perspective, it does text classification, question answering, document summarization, text generation, right? These are some of the application of it. And that's the evolution. We talked about the history, right? So there was something called in the 60s, ELSA. You ask it a question. It was rule-based. If the question said this word, then do this, do that, and then a lot of algorithms until something called RNN. See, these you might see them somewhere. So that's why I'm just bringing them. RNN, LSTM, and then the transformer was the big moment. That's what I was talking about, Mahmoud, the BERT and the GPT, started to appear. But then the actual useful one was in 2021 and 2022 when they put it into applications. Yes.
Brian, like history
Yes.
perspective, who is driving all of this innovation? Is it OpenAI?
So it's been until the 2010, it was always the research labs in big universities, in R1 universities. Yes, there was an early effort from like specific labs, like Bell Labs and Alexa, which turned out to be Alexa today. Sorry, not Alexa, Siri, right? The Siri team that was acquired by Apple. But it's been research until these companies came in, like OpenAI started in 2015, and then they started driving. Because what happened here, because of the compute. Remember when I was telling you about Exceed, the Exceed was an effort from NSF to bring all the compute in America together. Meaning, we have a supercomputer in Mississippi, a supercomputer in Champaign, Illinois, a supercomputer in New York, a supercomputer in North America, South America. Someone wants to discover the black hole, right? Like to reconstruct it from actual data. What do we need to do? We need compute. This huge compute. One supercomputer was not enough. How do we give 5 days to these researchers and just give them like a huge multiple clusters, go do your computation, bring it back and show us something. OpenAI partnered with Microsoft. That's why they became who they are today, meaning you need a lot of money, you need a lot of investments. You have a president now who wants to cut funding, and he's making it hard for people. That's why he's just making the billionaires more.
So all of the credit comes from the universities they start their work.
Yes.
Then all of the credit goes to the company.
Unfortunately, yes. I mean, that's the world, right? Yes. Any questions here? All right.
Google. Why didn't Google come up first, even though they had this?
They were skipped.
Was it a business reason or a technical constraint?
No, definitely not technical. They were the ones who invented transformers.
But like what Ilya Sutskever, like from OpenAI,
Yes.
figured out, like the GPUs and the data, which Google probably for some reason.
No, they have it. I'll give you an example. This is an insider. So Amin Ahmed, a good friend of mine, he has a company. He built a company called Victara. Now he's, mashallah, on his second company. Amin told me that not only him, a lot of other friends who went and started other companies. They told me that they worked at Google Research, and then every time they go and ask for commercialization, it takes forever. There was some sort of, decision problems basically. They were not commercializing enough. Yes, a lot of research comes out, but they're not commercializing it. So he left because of this. A lot of people left because of this. He was part of the Transformer team. Like, he did not build Transformer, but he was part of the research team at Google. By the way, it's just funny. The Transformer paper, go and read the paper, the founders. Every single founder has a unicorn by himself right now, right? Because they were fed up. Like, they come up with research, nothing happens, but Google started to catch up now. Clear?
Yeah, even the founders of OpenAI themselves, they split.
Yeah. It's going to be always like this. Anthropic came out of OpenAI as well. So Andrej, who was part of the original OpenAI team, is saying the hottest language is English, and rightfully so, because that's the language now agents understand, and it's a different mindset. So the way you write, if you're a traditional programmer, you're going to find it a little bit harder to start adapting into this. And now you have companies like Duolingo, Instacart. The main interface is in English. You go to Instacart now, you say, "What's a healthy lunch for my kid?" And they give you all the they put in your cart, the right things, or supposedly depends on your prompt, what you describe. So I'll focus on Meta, but I want you to distinguish between the foundational models, meaning like everything that is built upon them, like the OpenAI, the Anthropic, the GPT, the Claude, the Cohere, the Hugging Face, all of these models, and the platforms, meaning you have AWS have something called Bedrock. It's the place where you go and build your applications, for example. Vertex AI, Azure AI, and IBM Watson as well. These are the platforms, the cloud AI platforms, and then you have the models. Unfortunately, only Google has their own model. AWS had to partner with Anthropic and others to actually bring these models there. Microsoft had to partner with OpenAI to bring this model there, but only pretty much Google, to your question, are the ones that actually own the entire stack. They even do the machines themselves. Okay, so what's inside? What is this LLM? What is this file? Two files. You can go to, if you go to Hugging Face, which is like the GitHub of machine learning models. You can search for Meta Llama. They have smaller version of it. It's 8 billion, and I'll explain what billion means. And there's another one that called 8 billion instruct. So the one that you will be using is called 8 billion instruct. So it's a file that you download. What's inside this file? So when you download it, you have two files. One that runs it, which is very small. The other one is called parameter files. It's called what? Parameters file. It's about 140 gigabytes. Where does this 140 gigabyte comes from? Right? It's about what? When we say 70 billion, it's about 2 bytes. Like each number has what? Can be represented. So you do the math, you get the 140. It's about 100 lines of code just to manage how these ones work. But literally, if you open it, it's a bunch of decimal numbers. How come you ask these decimal number questions and it gives you that answer back? And that's what we're discussing. It comes in different flavors. I'm just picking up one model. Why am I talking about this? Because this is an open source, so we know exactly what's in there. When I say, sorry, it's open weight, not open source. There's a difference between open source, open weight, and sitting behind an API. So an example of a company that has a model that sits behind an API and you have to pay every time you ping it is? Anthropic. Okay. Llama from Meta, and we don't know why. Of course, I'll tell you why. They give it for free. They spend millions of dollars in computing these models, and they give it for free. The third thing is open source, meaning you have the source code that actually built this, and there's only a few ones. One of them is called Bloom. If you can, it's not the best, but that's what happens. You download these files, you use something called Ollama just to run it, and then you'll be able to chat on it on your computer, especially if you download the 7B, because you can have it on your laptop. But the 7TB is huge, and you need a server. That's why people pay for the server. You can use Llama, the big one, but you have to use it on a cloud, for example. Whereas OpenAI, they'll charge you for serving the model and using the model itself. Now, what's inside the model? Where does the 70 billion coming from? This is the huge matrix. It's a huge matrix. Like the numbers are in a huge matrix. So there's different layers inside. Something called embedder, key, query, value, output. I'm just trying to get a little bit technical so that not to be boring for the technical ones. And then if you sum these parameters, they give you, this is for GPT, by the way. They give you the what? The 175 total weights, which is how big the model is. So again, they took just like any machine learning model, bunch of data, an algorithm, and now you have the model, right? Have you guys used linear regression? Are you familiar with linear regression? Okay, so what do? You have data, you have an algorithm, or you have like a function, and then what's the output? It's the weights, the coefficients, right? These coefficients are the model.
It's a line.
Yeah, I'm just saying, yeah, it's the line. So yeah, the coefficient that constructs the line is the what? Is the model itself. So think about this huge file as the what? The knowledge that was extracted from the data to give us that knowledge. So you have data, you have the transformer architecture, and then you end up with the what? With the weights inside this file. So as we mentioned, billions and billions of tokens, actually trillions of tokens, chunk of the internet, a little bit of science, a little bit of biology, a little bit of, they just constructed this data set from everywhere. They prepared it in a certain way. They threw, this is for Llama 2. This is based on Llama 2, 70B. They threw about 6,000 GPUs, right? I think we have a GPU here, no? Yeah. Do we? Oh yeah, we have a GPU. So 6,000 of these, not this one, the big ones. This is H100. It cost about, it used to cost about 15,000. Now it's about 45,000. I just bought 8 of them in Saudi, and it's getting bigger and bigger now. But you have 6,000 of them, right?
It's not cheaper?
No, because the demand, OpenAI just bought the next 100 million compute from from NVIDIA. Nobody's gonna, give you, there's bigger problems to solve, basically. So that's what happened. Chunk of the internet, you have the transformer, the algorithm computed on a lot of GPUs, and now you have a file that is 140 gigabyte that lives on a server that everyone is querying. Of course, in the case of OpenAI, it's getting bigger and bigger. This 140 is probably way, way bigger now. And it's not 70 billion. Last time they said they're already in the what? In the trillion parameters. Just to tell you, like, as he said, it's scaling. The more they scale, the more intelligence, they can crush all the representation of the language and the knowledge of the world in one file. Does that make sense? Isn't that beautiful? Crazy? Yes.
Scary.
It is scary, yes.
Should the query not be slower with all of this, expanding?
Yes.
It is slower?
No, it's getting even worse. Like, what do you mean by slower?
The query itself. Talking to it.
No, there's multiple ways to solve it. Like the query used to, like back in the days, you used to hit all of these matrix to get the answer. Now there's like so many ways to go around it, right? We'll explain them, hopefully, if we have time.
So it's like $2 million, right?
Huh? So how much does it take? So just to do this smaller scale. By the way, Llama 2, does anybody use Llama 2? No. It's even, like, it looks so stupid. Back then it was like, wow, this is crazy. It's not enough anymore. It does not, it's garbage now. Llama 3 came out Llama 4 came out afterward. I'm just telling you how much it took to compute this because this is open information. Now these companies are hiding this information because they don't need people to know. Some paper comes out. Some of them are more open than others, but definitely OpenAI is the most secretive one despite the name. Yes.
So you need a lot of GPUs to create these files, but do you also need a lot of GPUs to use those files?
Yes. So this is called the training stage. Remember, they are what? We said they are pre-trained. Once we have them, you need to serve them. Nobody will have, in this case, it's about 140 billion parameter, right? 140 gigabyte. You know, if you try to serve it in your computer, it cannot, it'll crash. So you need a server. Now to hit that server, they'll charge you for running it, but they're not gonna charge you for asking the questions. Whereas OpenAI, every time you ask a question, they charge you for that question. Does that make sense? Yes.
Ebrahim, till 2023, when you talk compute and like the volume of the data, you train a model on the entire internet. When we said compute, like in the background, we thought like CPUs.
Yes.
At what point there was a realization, no, we have to move to GPU processing?
Okay.
And make us appreciate, why does it take so many GPUs, these huge data centers and gigawatts, in these like behind the scenes?
Okay. When did we go from CPU to GPU? So CPU, they're sequential, meaning like you give it instruction. Probably computer scientists here in the room. Okay, you give it instruction, right? Each one has to execute before the other, meaning it has to be sequential. GPUs, it was originally designed for graphical processing unit, GPU, right?
Gaming mode.
For gaming. Yeah. Why? They found out that for gaming, I don't need, like, it's very slow to compute on CPUs. It's a matrix, right? It's pixels. What do I need to do? Just compute each segment by itself, throw it to a processing unit, and that was the birth of the GPUs, basically. It, like, you can process it and then collect it together.
But that didn't happen in 2023.
No. This was way back in 2000.
The GPU.
Yeah, the GPUs, but way back when, 14, 15, who has the information?
No, I meant the GPU and the training of the LLMs. When did
No. Deep learning has always performed on GPUs.
Okay.
Yes. But then it was for a specific use case, small, and now we're trying to create, what are we trying to create here? We're trying to create a model that does everything. Back in the days, and I'll explain this when I come to deep learning, I'll come to this part. I have it in the next one. But you get the idea. Now, why do I need this? Because there's so much data and there's so much compute that needs to take place. Why is it so much compute?
Yes.
You're talking about billions of parameters, meaning, you know how many vocabularies do we have in English?
50,000 something.
Let's say 50,000 for now. 50,000, you need to put every single word in just to create the embedder, which is this one. Just the first layer, right? I want to create the first layer, the first matrix. Just think about it. You need to get all these 50,000 in the rows, as rows. And I'm saying words, but originally they're tokens, and I'll talk about what tokens is, which is a little bit less than a word. And then you need to do the same thing in the columns, and you need to compute the what? How far this word from that word in that context. You see, that's where you need a lot of compute. And this is just for the first layer. And then you have so many other layers that you need to compute. And every time they come up with new ways to make it even, it needs even more and more. But again, data and compute, yes.
Do they use matrix algebra in the, the calculation?
Yes. They use linear algebra. Linear algebra, yeah, which is how to compute the matrices. Yeah. So I'm not going to go into the math, but these are some of the architectures that we were talking about. Back in the days, for example, RNNs, or LSTMs, just for one specific language task. For example, classify a whether a sentence is positive or negative, and I'll show you an example with this. But now with the transformer, this architecture can adapt to many tasks. It could pretty much cover all the natural language processing tasks, basically. I'll give you an example before I go here. Let me show you this example. So with machine learning, for example, I would write this code, right, to pretty much do what the LLM is doing. So I'll initiate my functions, I'll create the embedding, I'll create the algorithm, I'll put the sigmoid, which is basically the thing at the end that will tell me whether it's let's say positive or negative, and then I'll do the calculation, right? I'm writing an actual code. But because it's an LLM, meaning it's based on the language, based on the token, I'll explain what that is. You talk to it in English and you say, classify this. This is my instruction. And this is my review text, an example, right? And then it will be able, just by talking to this file, it's able to what? To tell me whether it's positive or negative. This is from a high level bird's eye view. There's so much technicality into it. Now let's go back to how these things are created. So now we have trained it, we have the file, right? Now somebody said, how much does it need to? Yes, now this is the inference stage, meaning I give it a sentence. Now when it's trained, it's not ready to ask and answer. All it does is it gives you the next token, it gives you the next token, it gives you the next token. Cat sat on a, give it to the model. A lot of computation is going to happen, embeddings, all that stuff. And then it's going to find probabilities of different words. It's going to find the best word. And it'll say, oh, Matt, I've read all the text of the internet. And because I've read all the text of the internet, I know that Matt is the most probable word that is next. And based on this, every single generation of the word becomes after. Now, the funny thing is, if I come to someone, I give them a book, and say, read the book. And they read the whole book. And I say, predict the last word in the book. And the hero, do you think they will be able to answer? Yes, they read an entire book. The probability of guessing the next word is actually way, way higher. Does that make sense? And that's pretty, this is just an intuitive way of thinking about it. So the models until GPT-2, all they do is they just what? They spit the next word. So you say Matt, and then next. So for example, you say, my name is, and then it gives you a name. I do this, I do that. It continues. It just finishes. When do they start to answer? When do they start? This is the instruction. So every model that we generate, you have two types. You have the original model that just finishes the next word on Hugging Face, and you have the instruct, meaning we instruct it to follow a certain pattern. And this is very important because when you build your systems, most of these are chatbots, meaning like you question, answer, they're based on this. But you can do more if you actually use the original file. And I'll tell you how that is done. Now, let's go back. So because it started to spit, now it starts to dream. It gives you a Java code. So it's read all the Java codes on GitHub and different places. Now it knows how to continue with good probability. Similarly, you ask for an Amazon product, and now it knows how to continue. So it starts dreaming about these things, right? But then this comes the second stage. So first, pre-training. We have it. It costs a lot. And then comes that instruction. I'm trying to, remember the two files I showed you? I'm trying to create the second file. This is what companies are doing. And also, small companies now are doing with instruction. They take the original file, and they do the instruction. We sit about 100,000 question and answer. Say, for example, I want to train a model. So I have a model. I want it to focus on, say, for example, biology. So I'm going to set up questions, 100,000 questions and answers of biology questions. And now it learns how to follow. You give it a question. Now it finishes the question with what? An answer. It's still the same way. It finishes, but it knows that this is a question, this is an answer. And this is how it's done. So you ask the question, right? Can you write a short introduction, and this is the answer. This is how the data set looks like. So again, just to recap, used to take every year, not anymore. OpenAI, they have this habit to train every probably other quarter, every 2 quarters. It depends, but this takes a very long time. You download a lot of data. This is becoming bigger. I'm just telling you about Llama 2. You get a cluster of a lot of compute. You compress using the algorithm. You wait for about 12 days in that case. Right now, it's like probably months. And then you obtain what we call the base model. Now, you fine-tune it. That's what happens. You hire people that write these questions and answers. That's why these companies, that's why you see the lawsuits. Why do you see the lawsuits? With, for example, from Washington Post and others.
The copyright.
Because they just take this, they didn't do anything, right? There's a company called Ryder, the lady I showed you in the beginning, May. She built her models. She hires people from Stanford, Harvard, just to write these to write the knowledge from scratch, or she buys them, and she trains based on this. When things becomes when data becomes a problem, because right now nobody knows much. When it becomes a problem, copyright becomes a real problem. Then, such companies will survive. The big ones, Allahu Alam, what's going to happen with them?
So today, if I ask it for information that I know is behind the paywall at the New York Times or the Washington, it's not going to give me that text or that answer today.
No, if that knowledge was trained, then yes. See, it's an imagination. It's not like word for word, but it was trained on that probability. So the style of that writer, and sometimes actually, like research shows that sometimes they'll find actual, it'll spit it word to word.
But that's the reinforcement learning.
No. Well, I'll come to the reinforcement. We're talking about base file. We're talking about instructions now, right? So the reinforcement learning comes here. So what we did is we pre-trained it, right? Now we have the base model. We fine-tuned it to do specific tasks, right? How do I fine-tune it? I come up with examples, 100,000 examples at least to actually train it. So much reinforcement learning, human feedback. So many things happens. And then of course here, just for safety, for example, hey, if you ask it, create a bomb for me. You give it, this is embedded in the model. So hey, do not spit the answers. Do not do this. Do not do that. That's where it comes. And of course, this is back on the days. A lot of things have changed since then. I'm just giving you like an overall idea what's happening. So companies, I'll come back to so if you were to build things without a lot of restrictions, use an open source, use the base model, and fine tune it to your use case. Yes?
This is from a slide way back, but so this is generation that's happening with those models that you showed to us.
Mm-hmm.
What happens with the question, the stuff that you feed to it, the query that you give to it? How does it process that? Is it with the same mechanism?
Same exact thing. So the query goes into, so you take the query, it gets converted into embedding, which I will explain soon, which is like think about it as number representation of the same word. And then it goes through the architectures as I mentioned here, right? Think about this as a query. It goes in, it does the and then it spits the next one. And it keeps repeating. So you see ChatGPT when it's that's exactly what's happening. Does that make sense? That's called inference, but we're talking about what?
Which one is it open parameter now?
Open parameter? The Llama, Mistral, huh?
The large model?
Yeah, large language models, yes. These are open source. So Mistral is open source, not all of it, most of it. If you go to Hugging Face, you'll see a list of them. All of the open source are there. Meta, and the other ones are closed. Yes.
Can we go back to the cat sat slide for 1 second about this question?
Which one?
Cat sat on, you had 4 inputs.
Yes,
and
this
had
one?
output.
Mm-hmm.
So at some point, I'm in a fellowship with 20 PhDs, and we have a custom AI, and we're training our problems. And that word cat is now becoming almost my intellectual property or my social security number. How much can I trust that I'm training the next model if I give it my social security number?
So,
And if they're giving it their PhD
yeah, most likely you're not training a model, but you're inferring a model. But you need to be careful because OpenAI is free for a reason. All of now they don't have to hire people. They have good questions. They have good answers. You even give them feedback. This was bad. This was good. At a certain time, if you remember, they used to give you 2 answers and you tell you pick one. This is their training. They don't have to hire people to write 100,000, for instructions. So be careful. You put your social security, it's gonna end up somewhere in a model. That's why companies are super duper scared, and they tell their employees, do not write anything, because Samsung, one of their important intellectual property was actually breached because an employee just uploaded the PDF file, and the model actually said, start to learn because it's for free, right? It's gonna go there. Right. I'm gonna speed up a little bit so we can have a lab. But basically, this is after you leave. If you're interested, go download Olama, which is like a framework, or maybe LLM Studio, one of these, and then play with these models. Like, don't just use things behind the APIs. Try to download it. Try to interact. It's gonna be a little bit challenging, but if you can reach that level, then you will really understand what's going on. I talked about machine learning and AI learning. Back in the days, we used to get late data. We need to train an AI model and then deploy it, and it takes about 7 months as a machine learning engineer. Now, I can develop faster. I can do more applications faster just because now I just type it in English, or maybe I ask it to generate certain code for me, and now I'm able to deploy the model in weeks just because I have that file sitting up there. So not a lot of expertise needed to use these models for your application. Of course, if you need to build them, that's a different story. But to infer and to get something useful out of them, you don't need much expertise, as we mentioned here. This is how a machine learning engineer would use. It'll take him weeks and months, probably years, to collect the data, construct the model, do all of that stuff. But again, they used to do the same thing that is done, but on a smaller scale for specific problems, right? And this company now has an AI that does this because it's very specific. But these language models are a whole different beast. They're solving they're solving the world problem, the language problem, right? And we'll talk about how it does. Okay, now I have this model. I want it to work for me. I want it to work for me. I want it to work for my problems, whether it's at work, whether it's about companies. So how companies like Incorta that manages billions and billions of records for companies like Broadcom. We were with Incorta. Broadcom was with Incorta when they were only $15 billion. It used to be called Avago back in the days. Even their stock is called Avago. And now, mashallah, they're what? 1.5 trillion? You guys know that? Yeah. So we manage all of this data for them. Now, how do we use this to meet the needs for a company like Broadcom, for example? So we have the foundational model, and you have the enterprise data. To get the foundational model to do what you want them to do, there are 4 steps to do it. There's the pre-training that we talked about. Now you know what GPT is, right? So when you go home, I know can somebody tell me what GPT is? Generative, pre-trained, transformer. What's transformer? It's the algorithm. What's pre-trained? That's the process. What's generative? It's not classification, it's generative. Anyway, companies like OpenAI, OpenAI and others will pre-train. Usually, companies don't do that. This is where the magic happens. Prompt engineering, you probably heard of this word, and you craft certain, you word your words in a certain way to get certain behavior from the model. There's RAG, retrieval-augmented generation, which you're going to be practicing today. And there's also fine-tuning. Fine-tuning, it's similar to instruction. You see the instructions that I told you about 100,000? So basically, you take the base model, you come up with a data set with questions and answers, and then you retrain that again. You will need not as big of GPUs, but you need enough GPUs to actually do this. So big companies actually do that. They fine-tune specific models for their own need to do specific tasks. But once you fine-tune it, be careful. It's going to focus only on what? On the 100,000 questions, whatever you put there. So you put garbage in, you get what? Garbage out.
Where does the human feedback fall into this? Well, it's not applicable here.
So where's the human feedback? I told you, this is like during the fine-tuning, right? Here, reinforcement learning, human feedback.
It's part of the fine-tuning process?
Yeah, so what's the human feedback? Meaning it gave you an answer. You say, no, that's not a good answer.
Okay.
It learns. Yeah, you're fine-tuning it.
Okay.
Again, guys, I'm very abstracting. I could go deeper, but
No, this is good.
I'm just giving you enough to, to start using them.
Ibrahim, you talked about the...
So anyone online who understands, how this works, and I'm very when you abstract, you might miss
the 100,000 questions that you said. Who is inserting these questions? Are those like the users?
No.
Like from biology?
No. A company like the company that fine tunes hire people, experts, because they know what's an answer to something, and they teach the model, the base model, how to answer in a good way. And it takes these 100K questions, sometimes it goes to millions, depends on. OpenAI are the kings, of course, of such thing. That's why their models are really good, because the more you fine tune it, the better you instruct it, the better answers you'll get back.
Someone can say this 100K questions can be auto-generated also. AI can generate those.
Yeah, but it's not going to be.
But that will direct
Yeah,
a lot.
usually that's what happened. Nobody's going to write these. So you let AI does some, and then you go and
And then you do, okay.
you correct it, yes.
Will you be covering the eval portion in this workshop?
Of course. You remember I said in the beginning, I said 12 days they wait. You don't want to wait for 12 days and burn $12 million and discover that things were not. So there's checkpoints as they go. They check. They have to sometimes go back and redo the whole thing. And this is the IP. This is why OpenAI is better than, for example, other company, and this company is other than other company. And they're not going to share that with us, unfortunately.
So Ebrahim, they trained it on the internet.
Yes.
So what is there for it to get any better if they consume that?
Guess what? We ran out of data. We ran out of public data. So they're now after private data, meaning they go to Washington Post and they say, hey, we need your corpus. We're going to pay X amount of money to license it. And now the data on the private servers go there, right? Now they go to companies. They're like, hey, give us your data. We'll train the best models for you, so it becomes specific, right? Does that make sense? Data is money, so whoever has data. That's why your companies don't want you to put their data online, right? But we literally run out of public data. Yes, a lot of it is generated daily, but that's not enough to, like we hit a plateau. They're not getting smarter. They're now thinking, huh?
It's niche.
Yeah, they're thinking now of what do you mean by niche?
In Egypt, niche is something you buy when you're setting up a new
I know the niche. Yeah, it's like and nobody uses it.
Shape of the cups, yes. So niche means I'm a teacher, but I'm only going to teach a small group in my exclusive country club
Yes.
teaching, and then you're an engineer, you're only going to.
In that sense, yes, it is. In that sense, it is. Okay, so let me move a little bit faster. So now, because of these foundational models that were trained on not only text, but also images, speeches, structured data, 3D signals, now we can adapt all of them to do like question answering in that case, or maybe sentiment analysis, information extraction, image captioning, and even generating videos and others. So let's go to the first exercise. Everyone go to this file and click on the first exercise. I want you to go to Google AI Studio, google.com. If you don't have an account, make an account. And I want you to click. I just want to tell you that these models, because it doesn't matter how you query them, they're going to give you the right answer. Go to this link, click on it. And then go to chat. You see chat here? If you have not created your account, create your account. Go to chat and copy this question. The question is funny. So you can. The proper question is what? How do I tie my shoelace, right? But I'm writing it in a funny way. Like it doesn't matter. The order doesn't matter. Again, remember, it doesn't really matter. So let's see. Yeah, chat. Go to chat and run. By the way, Google AI Studio is incredible. You need to try it out. It has to be part of your day. So run.
Is it a free model?
It's free. It's free. You don't have to pay for it. You see?
Gemini versus this.
Huh?
Gemini versus this, like normally I would use Gemini. So
Yeah, this is Gemini. Google Studio use Gemini. It's from Google. You see? It's even generating the images for me. It tells me how to do it. See, the question was, shoe tie my eye, how do laces? And it did understand, because that's the context, right? It'll start generating based on this. It had enough instructions to follow, all of these words. It just needs to know where you are. What's the context? And it'll start generating the next word.
Does it know it's a hello world type of activity, or does it wouldn't like does it know? Let's say many guys use the same prompt.
Uh-huh.
Does it know it's a hello world?
No.
Okay. It's not that smart.
Yeah, you can change it to whatever you want.
Yeah.
Yeah. Does that make sense? Okay. Also, one of the exercise, and I want you to talk to the person next to you. I want you to go home. There's a model called Nano Banana. I think Mahmoud and I tried it. Where's Mahmoud? Nano Banana. Okay. Nano because it's small, banana because it drives you banana. That's why they called it. Upload a picture of yours and say, any picture of yours, and say, put it in a CEO for my LinkedIn profile, in a CEO clothing for my LinkedIn. And in less than 3 seconds, it's going to do that. Has anybody used it before? Please do it. Yeah. Just to tell you like how multi-model is doing. If you don't know how to do it, ask the one next to you. Everybody is in Google Studio? Okay, generate an image of banana wearing a costume.
Is there any limit for generating the?
Yes, yes. Google is going to get you enticed enough, and then they will. I've tried it for 30 minutes. I'd say like around 50 questions. That was good so far. No problems. And you can ask it anything. Generate slides, generate a poster, generate, and it does that. No, Gemini is closed source. It's not open source. They do have an open source that I shared also in the slide called Gemma. Okay, if you're done with your image, raise your hand. You have to do it. Seeing is believing. Or take any picture from the internet. You did it? Good? Looks good? Okay. Does it look real? No, not really.
Would it make me lose weight or something?
You can go to the details. Change my tie. You don't need Photoshop, by the way. Change my tie. Okay, let's take a pic. Look at this picture. Let me take let me take my own picture. Okay, I just pasted my picture and I say, very simple prompting. I said, make me like a CEO attire in an office.
It would be funny if I give you the same picture.
By the way, this image was made by AI, just to let you know. Yeah, look at this. Not bad, right? And then you can say imama, people without hair. You can try, imagine how you would look like with hair. You can take 2 pictures and say, sometimes you're not in a family picture, and you say, put me next to this guy and this guy, show this. The more details, the more prompting you give it, that's prompt engineering. The more prompting you give it, the easier it becomes. The reason I chose pictures just to show, because visual, it's easy to see. But also with text, you can do the same. Any questions so far? Are we done with this exercise? We have another exercise that we need to finish.
Ebrahim, if we get, the chat GPT-5 and the Google, are they comparable in terms of power and resolution?
Yes, I would say they're very close. There's something called LLM Arena, where you can see like how each model is good in what areas. So some models are better in math than others. Some models are better across. So usually GPT, Gemini, they're usually the best across. Right? And by the way, that's why. So we spoke about fine tuning. Can somebody explain fine tuning to me? So you have a base model, you have a data set, right, with questions and answer. You run it through the what? Through compute, and you get the unique needs that you need for your company. What type of data do we have? About 20% of the company's data are structured data, meaning they live in tables, Excel sheets, databases, ERP systems, right? About 20%. This is per Gartner, which is like an authority in this. And then you have about 80% of the data is unstructured, meaning it cannot be displayed in rows. You know, there are images, videos. And now with this power that we have, previously processing this data was almost impossible. With generative AI, now we just upload a picture or talk to this, it becomes much, much easier to do so. And I'll show you more examples. There's like even crazier example, like in marketing, it does the research. These agents are now doing even crazier things, you know. So think about an agent as, you know, you give it instructions, you connect it to an LLM. This is like the base way, the easiest way. And you give it some tools. And it figures out what you want and uses these tools with the brain, which is the LLM, to accomplish a goal. Where is that goal stated? In your prompt. And the more the prompt, the better. So now you have access to these data. You can extract data out of it. I have a friend of mine. His name is Mohammed Al-Husseini. He used, OpenAI actually cite his work, mashallah. He's a professor now at KAUST, but he worked for Facebook, Google. So he created an algorithm. He created an agent for videos, meaning you could have a Netflix type of videos, like as big as Netflix. And now you ask a question. For example, who's familiar with Shark Tank? So if I'm an investor, I don't have time to go and watch every episode. I can ask a question, say, hey, he created that algorithm and it's working. My mind was blown away. He says, show me all the seasons where Mark Cuban invested in clothing companies and they were females. And he gives them a table that has all the segments of the videos where a female showed up and Mark Rubio said, yes, I will invest, and how much, and like you could add as much information as possible. Like the more you prompt to it, the more you see the scale of us, like, and this goes on like a whole. Now, what does that mean?
Is it free?
No, you have to pay millions. But things are getting, cheap. These things are getting commoditized, right? By the day. Just to tell you like where you need to think. So, all right, so unstructured data, right? 80%. And in what format? Sorry, the pixel I got it from the internet. So structured data, relational database, data warehouses, example, CRM systems, ERP systems like SAP, Oracle, Salesforce, and that's where the data resides. That's structured data. And it's easy for the LLMs to work with because it's basically text to SQL, right? But then the unstructured data, that's where it becomes a little bit harder. So the RAG systems now, one RAG is better than other, and retrieval. You remember the retrieval I was talking about? Because of how do you process this data before you start what? Before these LLMs are using them. Research shows that open source catches up to closed source when it's in a specific data. Why? Because the experts would take that model, fine-tune it to their specific need, and they will get better output from that general purpose models.
How much traction did these AI companies get convincing companies to deliver their corporate data?
Usually these companies are very strict, meaning when you hear, for example, Databricks had a deal with, Databricks housed a lot of data for companies. Incorta, for example, housed a lot of data for companies. They have a deal with Anthropic, meaning Anthropic and Databricks, they got together and they said, okay, give us a copy of your model that we will host on our platform so that companies, because they trust us with their data, they trust us with your model. So that we make sure you're not training them. Does that make sense?
Yeah.
That's how it goes usually.
Just a question about the data before you move on. Okay, so the bread and butter for these models is the data.
Of course.
So,
And the compute.
Well, the compute comes after.
Which
but you need the
OpenAI
data first, right?
dominates.
And you say the data is infinite, right? So
Not infinite. Yeah,
I mean,
infinite.
Yeah. So
I mean
at some
finite.
point-
It ends. Yeah.
At some point, okay, you're not gonna, most of the data are gonna be AI generated. How do you prevent the data, like the data being used is actually, basically the AI start feeding itself
Yes.
data? So
Of course,
this is,
it itself is a big word. I would say, have you guys heard of thinking model? So remember the model would spit something, right? There's something called time test compute. Again, we're getting a little bit technical, but they figured out a way that, oh, we ran out of the data. We have the model just spits the next statistical word. Can we do better? You say, yes, we can. Before you spit, start thinking. And I'll show you an example. But for example, if you ask the model, the regular model, not the thinking model, a new class of models basically come up. You say 0.3 and 0.9, which one is bigger? What do you think the model would say? The regular model. 0.9 is bigger than 0.3. Is this correct?
Yeah.
No. Third of something is bigger than?
You're talking 1/3, not 0 point.
Yeah, yeah.
1/3.
Yeah, yeah. No, but it's the same. Zero.
No, 1 over
0. Sorry.
1 over 0.3.
Oh, okay. My bad.
0.3, yes.
Okay.
1 over 3.
So okay. Then my bad. But you get the point, right? Which one is bigger? It's just because it's seen that 9 is always bigger than 3, so 9 is bigger. But now you tell it, now that's where the new knowledge comes in. It says, oh, okay, I know what math is. This is a mathematical problem. Let's evaluate. If I put this and I add to this, it will give me a bigger number. And if I add to, okay, now this means this. Of course, what did this resulted? Resulted in better answers, but more compute. Because now instead of spitting one token, you're running. That's why in the new APIs that use from OpenAI, which you're going to be using today, inshallah, you specify, hey, think for 200 tokens. Don't think more than that. Because if you think more than that, then my bill is going to go up. But you see the motives of these big companies. Who is the winner, the final winner? NVIDIA and the cloud companies, right? Because they're the ones that host, and the more we consume, the more applications. Then, so you know where to invest. No, I'm just saying. Let's think. The reason of this again is to start thinking outside of the box. We need to have our own system, like in a way, right? It's gonna take years, but inshallah soon. Now RAG. We know what RAG is. You ask a question, and we will build a RAG afterward. You ask a question to a system. The system goes retrieve the right data. It brings the relevant information. It feeds it to the LLM because the LLM does not have that knowledge. This knowledge lives in certain documents. And then it generates the answer for you. Now, technically what happens is, first I have to index all of this, meaning I give it the data. The data becomes represented in something called embedding, which is basically a bunch of numbers. Why numbers? Because it's easy for me when I ask the question and convert that question to numbers as well. It's easy mathematically for me to compare what? Number to number. So it's similarity search. It's called semantic search. As opposed to what? Keyword search. A to A, B to B. No, now it's similar. And I'll show you an example. Meaning, if you have king minus woman equals queen. This is how the model thinks. Because in the plain, of all the words that we said, the 50,000 words, somehow the word king appears next to men, and the word queen appears next to woman. So it figured out when it was calculating that embedding that this word always comes close to this. T usually comes next to cub and next to, right? So it knows, it calculated all of that. So when you embed this, when you index this, it does that for you. So the better your embedding system or model, that's a whole other discussion. I will do it today. But the better you index it, the better the retrieval will become. I'll come back to you.
So it doesn't go to the LLMs first. It goes somewhere else.
Yes, it goes to an embedding model. It retrieves the right data, right? So you again, what are you asking? The question? The question goes to an embedding model.
Right.
It
It goes to the LLM.
No, finally. It retrieves the right chunk. It's not, you're not gonna feed, of course you can feed the whole library, but you need to retrieve only the things that you need so that you're not confusing the model. Even though now the models are becoming bigger and bigger. When Llama came out, it was 8,000. You can only feed it 8,000 tokens. Think about it as 5,000 words, right? Now, Gemini can take up to 1 million. And there's the research now, the next one is going to go to 10 million. So which makes RAG will always be relevant, but I'm just saying, like for big use cases, it makes it somehow useful. Yes?
Yeah, question of the use case of RAG and the difference between if we want to actually retrain our LLM.
Yes.
So technically both of them actually will add a new information to our LLM, right? So either you can retrain it or you can use the RAG.
Yeah. When do I use RAG, and when do I fine tune? Depends on the frequency of the change of the information. If you have a president like Trump who changes his mind every day, then you need a RAG, right? Because the fine tuning takes a week or probably days or maybe hours, but you need to.
And expensive.
And expensive. But RAG is relatively cheaper.
Is that what Perplexity did early when they connected it to the...
Exactly. So Perplexity connected to the internet, and now they made the models, but everybody's doing the same now.
Everybody.
They made a browser, and OpenAI just came up with a browser. Yeah. But I think what they have, what Perplexity has, that others don't have, is the market. They went to the Indian market before anybody else.
The Indian market.
Yes, that's why Sam Altman has been going back and forth to India, trying his best to penetrate that model. He's Indian, you know, the founder of Perplexity. So he made it for free. Yes. Okay, tokens. What are tokens? I want you to go to. This is not in the exercise, but this is an improvised exercise. Go write OpenAI tokenizer. I'll put the link in the file so that's easy for people. So you'll find it under exercise 1. I just put it here. Click on it. You will see the tokenizer. This will tell you how the LLMs see your query. So when Google or OpenAI are charging you per query or per token, that's what happens. So let's say my name is Ebrahim. I'm teaching a class on Sunday. You see here how many tokens I consumed? 12. And how many characters? 50. But this is how the LLM reads. My is my. The space with name, that's 1 token. Space with is. Ibrahim is not 1 word. It never sees Ibrahim as 1 word. So when it generates E and then Ibrahim. Somehow the embedding model or the tokenizer, remember the matrix I showed you? Each one is an engineering task by itself, a research by its task. Somehow they figure, this is wait a minute, this is which model? You have to ask which model is this tokenizer live in. So this is GPT-4 mini, but you can change it. If it's, for example, the old GPT-3, look how it looks. It changes a little bit. You see? The coloring is each token, just to distinguish it. This token is from a different token.
So mine is 1 token?
1 token, yes. Huh? If I try Ibrahim with I, wallahi, yes. I think it's going to take it as 1. You know why? Because it's seen so much text with I that now it recognizes it as. Okay. You're right. See, we have a scientist here. Yes.
So the difference between it recognizing it as 1 token or multiple tokens, like if you start writing your name as EB, that's 1 token.
Yes.
As soon as you put the next letter, it separates the E and then it puts the B and the R in another token. When does it do that process?
This is when you train.
Yeah.
So before you train, you have to train the embedder and the tokenizer. These are 2 different models. And then that's where all the rules are set.
Yeah.
And now the IP for companies is, oh, if we tokenize it in this way, we get a better answer downstream. If we tokenize it in another way, so again, it's trial and error strategy. Of course, there's so much research and knowledge, but we don't want to get into details. I just wanted to show you what a token means, so that when you when you build your application on OpenAI's models, you know how much is gonna charge you. Yes.
So mine is 1, but we've got Ebrahim 5, 6 letters as 1 too. So the size is not.
No, doesn't matter. But it sees it as 1. It sees it as a number. This Ebrahim with the space, this is just 1 number in the embedding space, right? Yeah. Okay. Any other questions so far? Let's continue the slides. Slideshow. Assalamu alaikum, Sheikh Hassan. How are you? Okay. So tokens and embeddings, right? Now you understand what that means, right? So we have 72 tokens, and then you have multiple types of. So how many? So large language model context. Remember the context I told you about? So this is 1 million. So all the latest models are actually in the million, and then you have 75 and others. Of course, this is an old one, so it has gone up. But this is exactly what happens. You ask a question. Remember, I take the documents, I tokenize it, embed it, and put it in a database. Now it's in a database in the form of numbers. It's saved. Now I come and ask a question. How fast should my internet be? I'm asking a file. It'll go, take this word, change it to numbers, which called the embedding. And now the embedding, I have everything embedded already in my knowledge base. It's just math. It's similarity. It could be design similarity. It depends on the algorithm you use. How far these words, because this is embedded from the same embedding of the text. So the documents and the query are from the same embedder. Now I'm asking similarity. It gives me chunks, because you have to chunk. There's so much that goes into RAG, but it chunk it, and then it embedded, and now it retrieved the right chunk, the right information, and now it gives me the result, right? So it transforms it into the query back, and then it brings it back. So maps in, maps out.
Why I need the LLM if I already have the information in my vector database?
No, you need the LLM to the query. Now the retrieved answer is going to be passed to the LLM as context.
As a new query.
Yeah, as a bigger query. You're after, this is just you retrieving, remember? Because the LLM does not have all the answers. You just retrieve the right information, and then you go from there. Okay, let's build our first RAG quickly, inshallah. Everybody, fire up your Colab. So go to exercise number 2. You'll see a Colab. Click on it. If you're stuck, raise your hand so I can come and help, or maybe Mahmoud and the rest of the team can help, inshallah. So you will have a Colab. You'll see a Colab. Try to make a copy so that you can change it to your liking. Sorry. So come here. Say, save a copy in my drive. Okay, save a copy in my drive. And then I want you to go ahead and run. So what's going on here? We're importing a bunch of libraries. Again, I'm abstracting everything for you. But I want you to appreciate what goes into a RAG system. This is a very basic RAG. I also put a complex RAG for you if you want to be a little bit more advanced, which uses 3 different technologies. Llama Index is a big RAG company that is out there. You could use their services. Weaviate is a huge vector database. Remember, we said we embed and we save it as a vector. Not the vector, from the statistic, but it's similar. It's actually similar to that vector, meaning it's a vector representation of the original text. So you save it in a vector database, and this is the model. This is the open source model of Google. It's called Gemma, right? If you want to do advanced RAG, but let's do this simple RAG at least in this class, and then we'll move on, inshallah. So what are we trying to do? Let me explain the code for you. So did everybody copy? Raise your hand if you copied. Okay. Anybody needs more time? It's okay. Raise your hand.
One comment.
Huh? Yes.
So these actually require the OpenAI keys, right?
I'll talk about this.
Yeah, but you can actually use Gemini keys as well.
You can.
Yeah.
Yeah. I'll give everybody one key that everybody can hit, but be careful. I'll explain that to them, inshallah. But yes, you can use any key. So that's why I said it's. So LangChain is a library. Anybody familiar with scikit-learn for machine learning? Yes, I see some hands. So this is the library that abstracted all the linear regression model. I don't have to go and build a linear regression model. I can just invoke that API. So LangChain came and said, hey, we're going to be that abstraction layer for anything GenAI. So if you want to talk to different models, we're going to abstract it for you. You just invoke, this library, and we'll bring the model for you. Just point us to the key, and we'll bring that things for you. And they have a bunch of stuff. Go and read about them. Interesting. But what I'm doing here is I'm importing a PDF loader. I'm importing, again, if you're not familiar with Python, this might look cryptic to you, but it's super easy. I'm invoking multiple things. So Hugging Face is where I find the embeddings. So what are the steps? So what I'm going to do is I'm going to bring this library called Hugging Face. It's going to help me interact with all of these components. What's the RAG component? I have an embedder that will take all the query and the text and bring it back to what? To its different representation, which is the number. I have the retriever that retrieves the data, like the similarity that I mentioned. And I have also the re-ranker. Once I get, let's say I'll get 10 chunks back. I'll get 10 answers that are similar to my query. Which one should I use? I need a system or a model that ranks these for me. Meaning, oh, this is actually the closest one to that one. These are all the similar ones. This is the retriever. These are all the most relevant ones. It's going to rank it for me. And then I'll take the highest ranker and then put it in the LLM, right? So let's try this out. So it's funny. I just took, are you guys familiar with MCWS regulations and policies? No? Okay, let's have the exercise. Let's have the exercise. So we're gonna download this file. Go to this file. It's here. By the way, it's gonna take you like 5 minutes to read it, but let's utilize the technology, right? So go to this file. It's under here. Just open it up, download it. Okay, so if you have an OpenAI key, you can use it. If you don't have a key, I'm just gonna give you my key. Please, just ask the question I'm gonna give you. Otherwise, you're gonna burn all my credits. I put a limit that is reasonable, so it's okay. But that's what's gonna happen. So let me share that key with you.
By the way, GenAI is free if you want to use it.
Yes, but I want them to use OpenAI for now. Yeah. So how do I try to follow the steps? By the way, if you can go and follow the steps, click on this OpenAI API, create an account. I want them to be practical because next week you're gonna put at least $5 in your account to start working. Okay, so go and create a key. Go and create an account with OpenAI. So you have the chat. OpenAI has multiple services. They have ChatGPT, they have OpenAI API, and they have Sora. So we're gonna just use the OpenAI API. This is how developers and people who are building applications use it, right? So go and if you click on this, you'll see the 3 services, right? ChatGPT, which everybody is using, the API platform, which we will be using during the weeks, and of course Sora, which is the video generator. So I want you to click on API. Sorry, not Sora. Yeah, you're not. I just want you to create the account, just to make sure that next time you're ready. I'm gonna ask you for.
Can I use API platform?
Yes, you're gonna use the API platform, and we're gonna generate a key, and that key will be used in the code here. If you go down, it says put your own OpenAI key here. Of course, there's a better way of doing it. You can put it here, right, where it's encrypted. But for the sake of simplicity for this class, we're just gonna put it. We're gonna hard code it, right? If I do this in my company, I'm fired. Wallahi, I'm serious, because this key could go public, and then it becomes a problem. Huh? This is a border. Yeah, this is recorded. It's fine because this key is gonna expire. Don't worry. Right after the class, and it has some money in it, so if it burns, it's fine. And it's my personal account.
Sorry, one more time from the OpenAI platform.
So everybody go to OpenAI platform. You will ask go through the steps. It'll ask you to put your information. It'll ask you to put. It'll say create a key. It'll give you a key. Once you have that key, don't put it. Just tell me that you have it. Because if you try to put it and use it, it'll tell you insufficient account. That's when I come with my key and everybody can use it. But I want you to have your own key because next week you will come with your own key. It has at least $5 in it.
I think you have to pay before you can create a
API. Okay, let me give you the key. As Brother Ali said, we do have, you can use Gemini, of course. And Gemini, it's free actually. Like, of course, free to some extent.
Yeah, free tier.
You can use the free tier. The reason I want you to do OpenAI because most of the examples you see online are done with Google. Sometimes some LangChain APIs won't take Google's key as a key. That's why I just want to make it as simple for everyone as possible. I've done these workshops, and I'm afraid. Yeah. So guys, let's go to. I'm gonna go to API. Did you download the file? The file has to be on the desktop. Run the first cell. Please run the first cell until I give you the key. You have two cells. Run the first cell, which imports all the APIs, all the libraries needed from LangChain, so that we can process this file. And as you can see, like embedder, the way to upload the file, the way to retrieve the file, the way to run the memory, and the way to start chatting with OpenAI. Once you're done, I want you to hover on put your Open API key here. If you want to know the pricing for each model, OpenAI is actually telling you how much it costs. So for GPT-5, which is their highest model, it will cost you about $10, right, for 1 million output, like million token, to spit out 1 million token. So they charge you per like in and out. So input and output as well. Money going back and forth. That's why a lot of companies use the open source that we told you about. Go to Hugging Face, try to download it, work with it. You will learn a lot. It might not be as good as performant, but once you learn how to fine tune it and how to work with it, it becomes much more performant. API. Huh? Yeah. Yes. Yes. No. I mean, it's doing it in the cloud, so don't worry about it. Okay. Let me just. Am I sharing my screen? Okay. If you're done with downloading the packages, please raise your hand so I know.
Sorry.
Yes.
Where do we go after we copy the key? I'm a little behind. Sorry.
Okay, that's fine. So here, once you have the key, right?
You don't have the
I'll give it. Sorry.
Oh, I'm sorry.
No, Jazakallah khair. I just closed the window that I wanted to. So once you get the key, go to the code, and then line number 26, you will see open API key. Just put your key there.
What cell is this? The first one?
This is the second cell. After you run the first cell and you have the output, you might see an error in the output. That's fine. Yes, I stopped the sharing. Let me share again.
Yeah, put your, okay.
Okay, we're good? It's still process what?
So the first cell.
So the first cell is run. Anybody got an output from the first cell?
Yeah. First cell we got some errors.
Okay. Second cell, put your API and run it. And I'll explain through the code. You should see, how do you know which API, which key? The key that you generated from Google, from OpenAI.
If we didn't pay for it?
Huh?
We generated a key, but I don't think it's
It's fine, just paste it there.
okay, great.
Just paste it there. I want you to experience the error yourself.
Yes, it takes 1 minute to put fact obviously.
If you want to.
Now he's ready to ask questions.
So once, so download the file. You should see something like this. Once you run it, it will ask you to upload a file. Do you see this? It says upload a file. Which file are you going to upload? The MCWS policies. Upload it. What's going to happen? It's going to take it. It's going to chunk it, embed each chunk, meaning represented in its number format, and then it's now ready. Now, when you ask a question, what's the question? If I advertise with MCWS, when will my ad be taken out of the wall? It should give you the answer. You don't have to read the file. And whoever is going to give me the answer first is the winner today, because we are about to finish, inshallah, in 5 minutes. It's in the document. Just copy and paste. If I advertise with MCWS, huh? 2 weeks. Can you verify from the file? Can you verify from the file? Go to the file and show me where in the file it says that. Let's see. It's not. It's not. It says too? Okay, alhamdulillah. So now you built, let's go over the code, by the way. What's in the code? Okay, so as I said in the beginning, what we did is there's a module that helps you upload a file, which you just saw. And this is all from LangChain, which is a library to orchestrate all of your GenAI applications for you. Hugging Face embedding, Hugging Face has a lot of embedding models. All the code went to Hugging Face, downloaded that model, and I'll show you where to invoke that one. Chroma is the name of the data, the vector database. Remember I showed you Waviate on the slides? That's another database. They're like hundreds, literally hundreds of vector databases. Even now, companies like Google, they have their own vector databases. MongoDB became a vector database somehow. Neo.js4 became, everybody is now in this, because now semantic search is a thing. It became a thing now with LLMs, right? What else? And the last thing here, conversation buffer memory. just to manage the memory, like what we retrieve. And the last thing is the chat with OpenAI. There's a module for it. If you're using Gemini, you're going to import the Gemini. If you're using Claude from Anthropic, you're going to be using the Claude. So they made it an easy interface for you to interface with all these things. Once we have the code.
So you just changed from OpenAI to Gemini and
Yeah,
it worked exactly?
don't do that. My advice to you is to go to the documentation and see it, because they keep changing. You know, they add more functionalities. But if you go.
But aren't they hiding it behind an abstraction? Otherwise, what would be the point?
No. This is talking about LangChain, the company that created this Python code for you to deal with what goes and comes back. So you're just invoking that library and you're using it instead of you writing the code yourself. That's it. It's an open source platform. So let's go and see LangChain. Yes, chat models. If you go to the documentation, you can ask AI too. But if you go to the documentation, you'll see all the chat models here. So this is all the embedding models, and that's how you invoke them. Just like an example. I hope I answered your question. Okay, so back to the code. If you're not familiar with Python, bear with me. But this is the module where you upload the data. That's how you upload the file, and you load it. You load it to the document through this function. Unstructured PDF loader, because you can also upload structured data as well. But it wouldn't be as much of a RAG, still a RAG. Here, we're calling an embedder model from Hugging Face called All Mini LLM L6 V2, version 2. L6 is another, like the naming to recognize it. But if you go again to Hugging Face, huggingface.com. So Hugging Face is an incredible company. Everything is open source. A few years ago, they acquired a company called Gradual, which became the interface for all of these models. Gradual was built by a brother named Abu Bakr. He works now for Hugging Face. I invested in his company. It was acquired. We didn't make a lot of money, but anyway. Just to tell you, alhamdulillah, we have amazing people in the community, alhamdulillah. So yeah, you go and you check for this model, and you might find maybe this chunking is not giving you the right answers. So for Arabic, you have something else, right? There's also an embedder for multiple languages. So you need to it's a whole science by itself. But then there's also platforms which I put here, like the company called Victara, where our friend Amin and Amr Abdullah started. What you do is you go, and this company, you can create an account. All you do, you don't have to code anything I told you about. You just go, log in, create an account, or put the chunk of the data that you want, ask a question, and then you have an interface. Oh, change the model, do this. You don't have to code anything. So this is an end-to-end RAG company. You can also build an agent on the top of your RAG. And now use that as an API in your, right? So that's why you have companies now come to do these type of things. You have a company that all it does is tools, MCP servers. That's all it does. And they excel in it. So everybody is standardizing on them, and so on and so forth. But let's go back to the RAG and continue. So we use this embedder. And this is just if it's not working. OpenAI key. Who got an answer, please? Everybody got an answer? Others? If you did not get an answer, please.
We got an error.
You got an error? What does the error say?
Just that the API is like has no
sufficient.
I
I know. So what I'm gonna do is I'm gonna be generous with the class, and I'm gonna create an API key. I'm gonna copy it. I'll put it, but I'll remove it immediately. Okay? So put your own key, and I'm being generous here. Allahumma sallim. Okay, this whole key, just copy it and paste it. By the way, this is part of the experience. I'm just giving you suspense. Why? Because wallahi, I've seen people like in my company misusing and mismanaging these keys. And they end up in a Docker file somewhere in. So you need to be super careful. And now I have this $7,000 bill because I trusted someone with a key.
There was a guy with a $70,000 bill. I saw. What did he do? Put his API key.
So I did get an answer, but I didn't get the answer.
You did get the answer, but you didn't get the.
I got a response from the thing, but I didn't get an answer. I said, I'm sorry, but the provided context does not contain information. Please contact MCWS for.
Really? What did it say? I'm sorry, but the provided context does not contain information about how ads. Interesting. Did you change something along the way? Because everybody probably uploaded the wrong file.
Rules and policies.
2 weeks.
2 weeks? Okay. And you can ask more questions. Learn about MCWS, please.
What's the question you need to ask, Ebrahim?
The question is in the file. The question says, if I advertise with MCWS, when will my ads be taken down of the wall?
Ebrahim, how much like this cost? You have like from the EBI.
How much? Okay, I've been bluffing, guys. I've been bluffing about the key and all of that. How much money did I put? $10.
No, how much from this one?
This one is gonna probably all of you. If all of you ask a question, it's not gonna be even 5 cents.
So I don't know what's going on, but I asked it who can use the gym, and it gave me an answer. Then I asked it the first question originally.
Still,
And no, now it's still talking about the gym.
it's still talking about. Okay, you need to do a lot of work then. So you know what's the problem? The memory. So the memory. It's not memorizing. It doesn't know where you are in the conversation.
Yeah.
So you need to that's all of the changes that you need to do. So go play with the code, please. Please, whatever you learned today, go play with the code because this will tie all of the concepts that we took today. Jazakumullahu khairan for coming. I just gave you a glimpse of what's possible, but we're gonna get a little bit more technical. So if your Python is not up to date, I gave you enough resources in the slides. So let me share the slides with you before I forget. And by the way, this is my LinkedIn. You can scan it. You can ask at any time, inshallah. I'm part of Medina Labs, and we would love, of course. So I'm going to share it with everybody. So.
Thank you, Brian. Thank you.
Well, yeah, barakallahu fikum.
What's that membership that we need to respond to?
Huh? Wallahi, I don't know. Affan, people are asking about the membership.
So I told everybody, Jazakumullah khair for coming. Inshallah, membership is through the website. You'll get access to a lot of the sessions and so forth. You know, more on. Sessions spent for the next 6 months. Once you have the membership, you have access to all the sessions, mentors, you have access to a lot of these, build
And you can train your own.
equipment.
The embedded is very
So
small.
there's a lot of benefit in having this membership. And all you have to do is just make an account on the website, medinalabs.com, and
Let's do that.
That's it. Any questions?
Inshallah. Before you leave, so I talked about the embedder. The embedder is small. Remember we said the model is 70 billion. You know how big the embedder is? No, it's in terms of size, it's actually in the megabytes. But in terms of like how many parameters, it depends. But it could go like to 50,000 parameter, all the way up to like 50 million parameter. Not billion, but million. Depends on how many dimensions you put. Like how many keywords. Remember I said 50,000, 50,000? If you make it 30,000, then you have a smaller embedder. So tokenizer is different from the embedder. Yes. Both of them learn.
How do you choose one size of
if it's in the millions, then it's a meaningful application. But depends on the task. If you have like, if I have a RAG about my documentation, it's enough to feed it the language. Of course, you need some general knowledge, but not much. It doesn't need to know about biology and chemistry. And does that make sense? So you just limit it. Any other questions? Jazakumullah khair. Any feedback? Please let me know.
Maybe a question is, how can a non-programmer use this experience to?
That's what I said. Like a company like Victara, you can just upload files and start using their services for like.
Yeah, but sometimes people don't have the end in mind. They don't have. I think the money now is knowing how to use this to create value.
Yeah, the more you know what you can do with them,
Okay, I see.
the more you find.
No.
If you can tell me what's the use case, that's my next $1 million. If you know how to employ these technologies, that's your next big company, right? Wa alaikum assalam wa rahmatullah.
So I had a question. So I'm a software engineer from old school maybe. So I just came here to see how the youngsters are actually doing it, because I feel that we need to unlearn a lot of things, because otherwise I don't feel relevant here. So I mean, good to see that not many are youngsters, so that was something positive for me. So my question is, okay, so we use, like, of course, Copilot and all that stuff in our, but not like we are using it for helping us in development or testing, but not as actually producing or developing something. So I had an idea, just that came up, like when you are watching streaming videos like Netflix or YouTube, right? When you are watching it with kids, you see something inappropriate. So I want a system or something that could, just blur the image or mute the inappropriate. So I'm a system, I should feed it with all the
Where's Omar?
So I mean, I'm just thinking whether this is something that can be done through an agent, or can I solve such problems?
Yes, it can, but you need a lot of knowledge with videos and how to process them. Remember when I was talking about the unstructured data? How to deal with the data itself is the problem. It's not how to extract information from it. It's how to load it, how to chunk it. That's the big problem, right? Yeah.
I mean, my idea is more like, what can I do with it? That is the biggest problem, right? What I have knowledge, I have a lot of, I have resources. Like my company also provides, like they have their own AI agent, everything. But the problem,
What company you work for?
I work for Entity Data.
Oh, mashallah.
Yeah. So, but to be honest, I don't know like how to channelize it or what to do with it. So yeah, that is what I'm looking for.
That's the $1 million question. Everybody, like, if we know, then that's my next big company, right? That's why people who are experts, let's say biologists or chemists, or once they learn about these, they know how to optimize their work now. So people with specialty, when they jump on such technologies, they excel more than anybody else because they have that knowledge. Imagine a lawyer knowing about RAG and understanding how it works, and now, right now he doesn't need to draft, and he knows how to make it work for them. He might hire even an engineer to do the work, but he has the ideas. Where the ideas come from, that's the job of the people now hire people to do things for them.
Thank you, brother.
بارك الله فيك. بارك الله فيك.
يلا ابراهيم حبيبنا
ان شاء الله كان مفيد.
اوه جدا
والله
جدا ان شاء الله.
بدنا نشوف the next billion dollar company. I need 1% بس ها.
ان شاء الله تعالى. ان شاء الله انا الاحد القادم هنا، لكن الاحد اللي بعده بكون خارج
البلاد.
خارج
ما في اشكال.
بس بتصوروها صح؟
ان شاء الله هي مصوره دائما.
يلا
شباب خلينا نعمل صوره مع بعض كذا.
يلا نعمل صوره.
يس يس. لسني.
تفضل
تعال اعمل لنا الصوره انت.
معك تليفون؟
معي تليفون.
ما عرفت اهلا وسهلا.
دكتور فاضل، ما شفت دكتور فاضل؟
لا والله اول مره اشوفه. حياك
ما شاء الله.
اهلا وسهلا.
نصر المدحجي. حياك الله.
هذا واحدة من يعني الهامات الكبيرة في ديربون. تعال سمعنا سيلفي. Let's take a selfie. You can take a picture. الله يجزاك خير.
You can do, yeah, that would be great.
Thank you very much. جزاك الله خيرا.
Thank you.
I'll send it to you. Yes.
احلى لو تصورت جنب الماشينز اللي ورا.
ها؟
هتكون احلى لو تصورت جنب الماشينز.
next time ان شاء الله.
الحمد لله.
كيفك يا بابا؟
الحمد لله.
الحمد لله. مالك ما حضرت المحاضرة؟
We were playing FIFA.
FIFA?
I guess I destroyed Abdullah 05.
ايوه وين اللابتوب؟
02
وين اللابتوب؟
03.
وين اللابتوب؟ ايش يعمل هنا؟
It's in the board.
بارك الله فيك والله it's an amazing session.
الحمد لله.
الحمد لله.
I'm
You
glad
made
you
it
found it.
bite-sized enough like
الحمد
for
لله.
the normal guy to understand.
الحمد لله الحمد لله. عبود كيفك حبيبي؟ فيفا وها؟
I destroyed him.
ما حضرتم الكلاس؟ لا. كيفك؟
Alhamdulillah, it's answering every question except this advertising question.
والله.
I have no idea why. I ask about like where can I donate? You can donate here for this. Who can use the gym? Right? When can you use the gym? It answers. Every time I ask it this question, it doesn't take it. Yeah.
I don't know.
Yeah. I have no idea.
Yeah, that's what I was gonna say. Man, it's a command. It kept on
Can
giving
it
me
query
sorry
the
as a
WhatsApp?
response.
Huh?
I was
Can it
confused.
query the WhatsApp, or does it have to be the PDF?
No, it could if you give it access. Like it depends on the system, but if you have a connector to WhatsApp, APIs, yes, of course you can.
Oh, sorry.
And you can say, for example,
Heavily dependent on WhatsApp.
huh?
Heavily dependent on WhatsApp.
Yeah. But in WhatsApp now you have Meta AI.
Oh, this is Lama.
Exactly. So you can ask it, and it will bring back to you the like when I don't know if it goes across chats,
Okay.
but it should be able to answer it.
Can I ask what mosque do you go to? Can I ask what mosque do you go to?
MCWS.
Okay, good. So we're local, we're neighbors.
Yes, alhamdulillah, alhamdulillah.
And then my question was about the Azhar. Tell me about that.
والله الحمد لله I studied in Al-Azhar for some time. Allah الحمد. I started online.
Please don't be modest. أنا كتب كتابي شيخ علي كمان. Just say them pizza. So when I'm asking, it's very.
ما شاء الله. أنا so Al-Azhar have a section for non-Egyptians. It's called الوافدين. الوافدين. They started this.
No, it's supposed to be using this file. This file has the word.
ما شاء الله ما شاء الله.
Like 2 steps away from Azhar.
الحمد لله. فأنا يعني I started during COVID. We started online. وبعدين كنت أروح وأرجع. My company has also a branch in Egypt. So I would go back and forth from time to time. Alhamdulillah, until I finished 2 years ago.
What did you study?
Islamic studies. Arabic and Islamic studies. هذا الاسم التخصص. لا undergrad اللي هو العلوم الإسلامية واللغة العربية اسم التخصص. علوم إسلامية. ونقول لك هو للوافدين. يعني we didn't have Egyptians. We did have some Egyptians who are American. يعني American Egyptian. لكن المصري مش مسموح له يدخل البرنامج هذا. They have their own track. لا المنهج هو نفسه يعني نفس المنهج نفس المشايخ. بس they account for الforeigners لأنه في كمان online platform وكذا.
عندنا في البابليك سكول accommodation وmodification.
Of course, yeah.
So how do they accommodate you غير المصريين؟
I don't yeah. المصري لازم يكون خريج المدارس الأزهرية.
طبعا.
الغير المصري لا مش لازم عشان كده they have a separate exactly عشان كده it's a separate